Hello students, let's discuss about what is a cardinal number of set today. It is a very simple topic. It is already we discussed in the previous classes about what are sets, unions, operations on sets. And now one more important topic, that is cardinal number of a set. Here it is a very simple topic. The number of elements present in the set will be called as a cardinal number of set. For example, here you can see I have taken one example. A is equal to AEIOU. A is equal to AEIOU. 5 elements are present. So we say that n of A is equal to 5. N of A is equal to 5. And here one important formula we have to remember is n of A union B is equal to n of A plus n of B minus n of A intersection B. This formula gives the relation between number of elements of union of two elements, number of elements in A, number of elements in B, number of elements in intersection of two sets. For example, to understand better, let us see this example. In this, it is given number of elements in A, 15 students are there, 15 elements are there in A, and in the number of in the set B, 21 elements are there, and A union B together overall 36 elements are there. Then we have to find how many are there in A intersection B. So by using this formula we can find out how many elements are there in A intersection B. Already we know A union B means what? Set of elements of A or elements of B together. Set of elements of A. N of A is set of elements of B. N of B is set of elements of B. N of A intersection B means set of elements, common elements of A and B. So by using this formula, let us solve this problem. Let's write the formula first. N of A union B is equal to, we know N of A plus N of B minus N of A intersection B. This is the formula. In this formula, let us substitute the given values. We know N of A union B is equal to 36. That is, here we have to write 36 is equal to, we know N of A is 15 plus N of B is given as 21 minus N of A intersection B. Now to find out N of A intersection B, we have to add these two and transpose that side. 36 is equal to 15 plus 21, again it is 36 minus N of A intersection B. So now if you transpose this 36 that side, 36 minus 36 is equal to N of A intersection B. So we got N of A intersection B is equal to 36 minus 36 is 0. We got 0. N of A intersection B is equal to 0 we got. What it indicates? It indicates that there are no common elements in A and B. In this case we can say that A comma B are disjoint sets, because already we discussed disjoint sets are the sets in which there are no common elements. So whenever given two sets are disjoint sets, there will be no common elements in that. N of A intersection will be 0. N of A intersection B will be 0. Here we got N of A intersection B 0. That means there are no common elements. They are disjoint sets. Okay, this is one example to find out. Let's see one more example to understand. One second, it's taking time to open next page. Yeah. These are the other two problems. Here also what is given? A and B are two sets such that A has 35 elements, A union B has 80 elements, and A intersection B has 10 elements. We have to find elements of B. So in this, again let us write the formula. N of A union B is equal to n of A plus n of B minus n of A intersection B. This is the formula. So according to given information, we know n of A union B. Let us list out what all we know. N of A union B is equal to 80. It is given. N of A is also given. N of A is equal to 35 elements. So n of A is equal to 35. We also know n of A intersection B. Even we know n of A intersection B also. So n of A intersection B is equal to, it is given as 10. We have to find out n of B. How many are there in elements? How many elements are there in B? So we have to find elements of B. And let us substitute all these values in the formula, that is 80 is equal to n of A 35 plus n of B we don't know, let us write n of B only, minus n of A intersection B is 10. Now we have to simplify 35 minus 10, 25. So 80 is equal to 25 plus n of B. Now to get n of B, transpose 25 that side. We get n of B is equal to 80 minus 25. 80 minus 25 is how much? 55. Therefore, n of B is equal to 55. There are 55 elements in set B. Hope you understood this solution also. Now next one more is given down. In a group 50 persons play basketball, 20 play football and 10 play both. How many play at least one of the two games? So here we know there are two types of games, one is basketball and other is football. So let us take the given information, let us write like this. N of, like basketball, let us take that set B. So we know that n of B is equal to, how many people play basketball? 50. So n of B is equal to 50 we know. And football, how many play football? 20. So n of F, let us take football as F. N of F is equal to 20. So they play 20 people and both of them together common. So that we should take it as intersection. N of B intersection F is equal to 10. Use the formula again. We know n of B union F, because here B and F we have taken, so we have to take B union F is equal to formula n of B plus n of F minus n of B intersection F. So here n of B is 50, n of F is 20 and n of B intersection F is 10. You know what we have to find out here? B union F. So that is n of B union F is equal to 70 minus 10, 60. So 60 people play at least one of the two games. This is the solution of this problem. Hope you understood this also. And here this is solution, n of B is equal to 55. So like this, by using this formula we can find out cardinal number related problems. Now we have one more problem also, that is, let's understand, to understand more better, let's see one more problem. One second, it's taking time. Yes, this is the another problem in which we have total 90 people are there. 90 people, in that 41 like jogging and 30 like swimming, 8 like jogging and swimming. Means what? They like both. So we know here one information n of total people are 90. So we know that is not in a group of 90 people, 41 like jogging, 30 like swimming, and 8 like jogging and swimming both. Then find the following. We know n of j, jogging means what? N of, let us take jogging as set of people in jogging with j. So n of j is equal to 41, and one more swimming, n of s. Let us take that as n of s. N of s is equal to 30. Now together both means we should take it as intersection. N of j intersection s is given as 8. Now the first question, how many like jogging only? How many like jogging only? That means, how many like jogging only means you have to find n of j minus s. Jogging only means they should not be there anyone in the who like swimming. Only jogging we want. So j minus s, n of j minus s. And n of j minus s formula is what? N of j minus s is n of j, we have to remember this now onwards, n of j minus n of j intersection s. N of j minus n of j intersection s. That is, n of j is 41 minus intersection is 8. So 41 minus 8, which is 33. 33 people like only jogging. 41 like jogging. In that 33 like only jogging. Remaining 8 like both. Hope you understood this. How many like swimming only? Then what we have to do is n of s minus j. N of s minus j. That is n of s minus n of j intersection s. So whenever you want only, then we have to subtract common elements from the whole elements of s. Total how many people like swimming? 30 people. From that who like both are 8. From 30 people, if you like only, when you want only swimming, from 30 people who like both, if we subtract, we get only people who like swimming, that is 22. So 22 people like only swimming. This is your first one answer. This is what second one answer, second question answer. And the third one, how many like at least one of them? How many like at least one of them means we have to find n of j union s. Formula, this formula already we know, that is n of j plus n of s minus n of j intersection s. We can follow this formula, or we have some other formula also. Let us use this one because all this information we know. This is 41 plus 30 minus 8, which is 71 minus 8, that is 66. 66 people like at least one of them. This is what. Next, D, how many like none of them? How many like none of them means we have total 90 people. Total 90 people. So, number of people who like, number of people who like none of them, when you want number of people who like none of them is equal to total we have 90 people, and in that we know 66 people like any one of them. So that 66 people should be subtracted from total people. So when you subtract like this, what we get? 90 minus 66. 24. 24 people like, 24 people do not like anyone jogging or swimming. So total 90 are there. 66 people like any one of them. 24 people do not like any one of them. Then same problem if we want to solve by using Venn diagram, we can draw a Venn diagram like this, and let's see how in a simple manner how can we solve it by using Venn diagram. So here we know how many people like both of them, that is 8. So we have to fill up that 8 in the common region, here 8. Then how many people like jogging? Let us take this is jogging and this is swimming. How many people like jogging? 41. In that already 8 we filled. Remaining how many will be there? 33. So this is what here we have to write. 33. Now 33 plus 8, total 41 people like jogging. Like that we have to find it. First we have to find common, then only jogging. Similarly this side also 8 already filled. We filled more how many people? Total 30 people like swimming. In that 8 already we wrote. So remaining 22 people we have to write here. So by this, if you want only jogging is the area. This is the area which like only jogging. This side without common region, only when you take this part, that is only jogging, and we know in that 33 people are there. So first question answer is 33. And the people who like only swimming is this side, only this part. In that we have 22 people. So people who like only swimming, 22. And we know common people 8. Common people are 8. Common people are 8. You know these common people are 8. Now when you want total number of people, we have to add all these 3. What you should add? When you want total number of people, 33. This 33. Then 8 and 22. All the 3 people we have to add, then we get total number of 66. Total 66 people like, 66 people are there who like any one of them. And 90 people are there, total 90 people are there. In that 90 people, 66 people like one of them, at least one of them. Then 24 people will not like anything. So in this way, by using Venn diagrams, we can solve the problems. Hope you understood this. In this way only, we will discuss some more interesting and complicated problems. Once sets is completed, we start relations. One more topic called as relations. Then we go to functions. Okay. Hope you all understood. Thank you.